Good morning students. Today we are going to start a new chapter, Semiconductor Electronics. You already know the difference between conductors, insulators and semiconductors. What is meant by a conductor? It is a device, it is a material which can conduct electricity. And you have already studied silver is the best conductor, then comes copper, then comes aluminum and so on. Now what are insulators? Insulators means those are materials which do not conduct electricity. Example, rubber, wood, paper, etc. Now what is meant by semiconductor? Semiconductor is a material which can partially allow the flow of charges through it. Semiconductor is a material that can partially allow the flow of charges through it. That means their conductivity lies somewhere between the conductors and the insulators. Okay. Now, what is the difference between electrical device and electronic device? I will give you an example. Here we have light, fan, television. Light and fan comes under electrical device, whereas television comes under electronic device. So what is the difference between these two? In electrical devices, the current will flow through the circuit and the circuit operates. The device will operate. That's it. The working is based on the flow of current. We cannot control the flow of charges through electrical devices. Whereas in electronic device, the flow of charges can be controlled. So the number of electrons which can flow through a material can be controlled as per our requirement. Such kind of devices are called electronic devices. So you can write like this: any action, any device whose action is based on the controlled flow of electrons through it is called electronic device. In earlier times we were using vacuum tubes, vacuum diodes, etc. You have already seen very big radios and all, very big radios and all times television. It is so bulky. On those models we were using vacuum tubes. Vacuum tubes means there is an evacuated glass tube where two electrodes are kept and we will adjust the voltage between the anode and the cathode. The two electrodes are anode and cathode. We will adjust the voltage between the anode and cathode, thereby controlling the flow of electrons from cathode to anode. So how much is the voltage that we are applying, that much will be the flow of electrons through that vacuum space. The glass tube should be vacuum, that is why it is called vacuum tube. And the advantage of those things are it is very bulky. If it falls down, then obviously it will break. It is made up of glass. Therefore, there were a lot of disadvantages for it. Now at present time we are using semiconductor devices. Semiconductor devices, the advantage itself is the size is very less, and even if it falls down, nothing will happen. Your mobile has been fallen down many times, but nothing can happen. You can just take it back and put it and it will work. So that's all about semiconducting devices. It is easier to operate, the size is less and it needs very less voltage. Okay, that is the advantage of semiconducting devices over the old vacuum tubes, vacuum diodes or triodes, etc. Now we will move on to the band theory of solids. Energy bands. in solid. According to quantum mechanical laws, the energies of electron in a free atom cannot have arbitrary values, but only some definite quantized values. So, if I take an isolated atom meaning single atom. In single atom, energy will be having a discrete value. That means, say for example, 1 electron volt. So, the electrons in those shell will be having 1 electron volt. There is no continuous value, there is only one value which is discrete value. Now, however, in an atom belongs to a crystal, then the energy levels are modified. Because if I take a crystal, that crystal consists of many atoms. The atoms in the inner shells are not getting modified because they are closely bound to the nucleus. But the valence electrons, the valence shell and the valence electrons, their energy will get modified because of this. So, the modification is not appreciable in the case of inner shell electrons because they are completely filled, whereas in the outermost shell, the modification is appreciable because the electrons are shared by many neighboring atoms. So, that is the reason behind it. The outermost electrons are shared by the electrons of the other atoms. As a result, their energy will vary. They will not have a discrete amount of energy. Discrete means they will not have a single value. Instead, their value will have a certain range. I can say like this, instead of saying 1 electron volt, I will say the electron is having a range of energy 1 electron volt to 1.2 electron volt, or 1 electron volt to 1.3 electron volt. So, such kind of range. Okay, and that continuous range of energy is called energy band. So, we can say like this, due to the influence of high electric field between the core of the atoms and due to the share of electrons, the energy levels are spread up to form energy band. So, what is meant by energy band? A large number of energy levels are closely spaced in a very small energy range, which is called energy band. Okay? A large number of energy levels which are closely spaced in a very small energy range constitute energy band. So, all the outermost shell electrons will have a certain range of energy, continuous range of energy, which is called valence energy band. If I take the first shell electrons, we can say the range of energy in first shell electron is called first energy band, and for the second shell electrons the range of energy is called second energy band, so on. Okay, so the energy level in the electrons in the valence shell is called valence energy band or valence energy level. There is one more higher energy level than the valence energy level, which is called conduction energy level or conduction band. Valence electrons cannot conduct energy, cannot conduct electricity. Valence electrons are bound to the nucleus, so they cannot conduct electricity. But if an electron receives sufficient amount of energy, they will move from valence band to conduction band. And as they move from valence band to conduction band, those electrons in the conduction band are free electrons. Those free electrons are responsible for conduction. So, conduction is actually due to the movement of electrons in the conduction band. Okay. So, we have studied valence band and conduction band. Valence band means the range of energy, the continuous range of energy in the electrons in the valence shell is called valence band, and there is a higher energy level than the valence band, which is called conduction band, and only if the electrons jump from valence band to conduction band, they can conduct electricity. Okay. Based on this classification, we can categorize solids into three: metals, insulators, and semiconductors, or conductors, insulators, and semiconductors. So let us see that. Here I have shown the energy band diagram of metals. Okay, energy band diagram of metals. In the first figure, you can see there are partially filled conduction bands. Conduction band is partially filled. So there are some electrons in the conduction band, and there is a very small gap between valence band and conduction band. The gap is very small, so that most of the electrons in the valence band can cross the conduction band. Now, with a little extra energy, the electrons can easily reach the empty energy levels above the filled ones, and conduction is possible. Now, this is applicable, this partially filled conduction band, that is applicable for alloys like nichrome, manganese, etc., or alkali metals like sodium, potassium, etc. Now, the another thing is the second figure. Look at the second diagram. Here I have marked the valence band and I have marked the conduction band, and you can see the valence band and conduction band overlap each other. So literally there is no energy gap between the valence band and conduction band. So all the electrons which are in the valence band can move to the conduction band. In short, all valence electrons are conduction electrons. Such kind of metals can conduct electricity very easily. Example, silver, copper, etc. Their valence band and conduction band overlap each other. So all the valence electrons are conduction electrons and they can conduct easily. Okay. Now, what is Fermi level? The highest energy level in the conduction band occupied by the electrons in a crystal at absolute zero temperature is called Fermi level. So, what is meant by absolute zero? Absolute zero means 0 Kelvin. So, at 0 Kelvin, the highest energy level in the conduction band occupied by the electrons in a crystal, that is called Fermi level, and the energy corresponding to this energy level is called Fermi energy. So, if the electron get enough energy to go beyond this level, then conduction takes place. So, the electrons, all those electrons that can cross the Fermi level can only act as conduction electrons. Okay. Now, see the next one. Semiconductors. In semiconductors, you can see the valence band here and the conduction band here. There is a small energy gap between valence band and conduction band, which is called forbidden energy gap. Forbidden means electrons are forbidden. Electrons cannot move, electrons cannot stay here. That is why it is called forbidden energy gap. And that value is approximately 1 electron volt. So here when you look, you can see that valence band is filled and conduction band is empty. There are no electrons in the conduction band at absolute zero. Okay, at absolute zero, that means 0 Kelvin. At 0 Kelvin, there is no energy, there is no electron in the conduction band. All those electrons are valence electrons only. So, at absolute zero temperature, the semiconductor will act like an insulator. So, look at the first sentence which I have written. At absolute zero temperature, no electron gets energy to jump from valence band to conduction band. Hence, the crystal will behave like an insulator. So think that point carefully. At absolute zero, all the semiconductors behave like purely insulator. Now at the room temperature, what will happen? When I give the temperature, when the temperature is increased, slowly the electrons in the valence band will break the covalent bond and they will jump from valence band to conduction band and they become free electrons. So as the temperature increases, more and more electrons will jump from valence band to conduction band. As a result, the conduction will increase. Okay, the conductivity of the semiconductor will increase. So I have written like this: the energy gap is represented as E subscript G. Okay, Eg. For silicon, Si stands for silicon. So for silicon, the forbidden energy gap is 1.1 electron volt, and for germanium, Ge stands for germanium, and for germanium the energy gap is 0.74 electron volt. Okay, you have to remember that value by heart. For silicon it is 1.1 electron volt, and for germanium the energy gap is 0.74 electron volt. Now as an electron leaves the valence band, it leaves some energy level in band as unfilled. Such unfilled regions are termed as holes in the valence band. They are mathematically taken as positive charge carriers. So what here says is, whenever a covalent bond is broken and the electron moves from valence band to conduction band, there is an empty space created in the valence band, which is actually the deficiency of the electron. That deficiency of electron is considered as a hole, which is considered as a hole that is equivalent to a positively charged. So you can assume like this: holes are positively charged. Okay, so as the electron will move, hole also will start moving. Electrons are there in the conduction band, holes are created in the valence band. So electron flows that cause conduction and that cause current, which is called electronic current. Similarly, hole will also move in the valence band. That current is called hole current. So in an electronic device there are two types of current: electronic current and hole current. Electronic current takes place in the conduction band, whereas hole current takes place in the valence band. Any movement of this region is referred to a positive hole moving from one position to another, and that will create hole current. Now see the next figure. Insulators. In insulators, the valence band is completely filled, whereas the conduction band is empty. And you just see the forbidden energy gap. Forbidden energy gap is 6 electron volt, about 6 electron volt. So even though if I give sufficient amount of energy, electrons cannot jump from valence band to conduction band. Okay, even though we give sufficient amount of energy, electrons cannot move from valence band to conduction band. So conduction band remains always empty, therefore insulators cannot conduct electricity at all. Okay, that's all for today. Bye.